Hello everybody, welcome back to another edition of the EcoStruxure Machine Expert training. I'm your host, Leandro Romada, and in this video what we're going to see is how we can encapsulate the code that we have done on the previous video using these communication blocks for the Modbus serial in just one block, so we can reuse it and have it like protected in a way instead of using the Modbus IO scanner. So let's go to the software. So in the previous video you saw that I have done all this. That basically is this ADDM, okay, with the function blocks. And this is fine. We just want to read and write a few registers. But what happens if you have multiple registers that you want to read that are not next to each other? Then the things can be a little bit complicated, okay, because you don't want to saturate the buffer. You just need to send the sequence the right command at the right time so you don't execute at the same time the Modbus. So what I have done is the following. I done this code, okay. I was trying to make the video and then I accidentally put the pause and I realized until I finished that I have done it. So and I'm going to do it again. So I have copied the same code that I have, okay, using the instance over here, the ADM, the command that I have done before. I have my oldest command that I have used for read and the write. So everything is going to be exactly the same. But what is going to change is the execution of that information, okay? So for that, I have created this action, okay? If you go here, you have this plus button action, and I create this function block that I call it, okay? And then in order to make everything much easier to have everything a function block, I have to specify these the input variables for these. Haven't specified, just bear with me here, the init to initialize the ADDM, and then this one to make the communication, and also an input for defining the slave address without using the string, just an integer variable. So for that, I have a concat and a converter to a string. So I use the commas.1 and then the slave, because this one is not going to change because it's Modbus serial. It would change if we use Modbus TCP, but that would be another story. So I have this. So what we need to check is in this sequence. So as I like to work on a structured text, when I do this, I have created this case. So the case is the one that is going to manage the how I check the information. So here I have two rising trigger that will take the rising edge of the init and the communication. So when this one is init, it will go to the state number 5, and the state number 5 will activate the ADDM over here, the X init. We can use the variable or the instance directly. Okay, so here I just wait for the ADDM to finish, and then I go to the next state. On the next state, I just wait for the signal to run the sequence of the read and bar. It can be, I can extend this, okay, in this case I just use 2 blocks, but it can be extended. So I have this, I'm just waiting for the signal. As soon as I have the signal coming in for, okay, ready to communicate with this device, I send through to the command to read, which is this one, command to read, and then I read the information I want, okay, to this in the same buffer. And I wait for this one to be done. If there is any error, we have the instant.error, and then I go to a different state, the 99, that I haven't defined anything, okay, so I go there. If everything is correct, I disable the command for reading, and I go to a different state, which is the 30. On the 30, as this one is writing information to the other device, I need to put the information that I want to write in the buffer and then send the commands. So I have done that. So I am the state 30, I send the values coming in from the function block, and then I move to the 35, which is the command to write into the other device. Okay, I'm just waiting for the done, and if it's done, then I go back to here, waiting for the command to communicate again. Okay, so in this way, I just wait for, if you have multiple devices coming together, okay, instead of having just this one in my case, you can have another sequence to activate one another after it's finished. Okay, of course, in my case, I make it simple, but we should be able to have like a done when it's finished, where an error message over here when it's finished, or when I have an error. Okay, so all these things we can add and make it more complicated, but this is like the basic. So just to show you how this works, so I'm going to send over here. I create this FB with the instance, so I'm going to initialize this. So as soon as you initialize, and if you go here and move it to the left here, you can see in state 0. As soon as I initialize this, if we go to the number 5, okay, and then now it's waiting for the command to send the information. So now I'm going to initialize this, the blink. You can see it's reading information coming from the M221. So I'm going to use 1, 2. You can see it's reading information perfectly. Okay, now what about the output? Reading, writing this part. Okay, it's fine. So here, where is the buffer? No, sorry. This is the instance. On the instance, I have this output coming in. So it's going to be 111, 222, 333. You can see that is almost updated over there. Now it's sending information. So if I go back here, 11, 22, and 33. So the idea of this is for you to create your own function block. Okay, of course, using this function block probably can take more time than writing using the IO scanner. Okay, the IO scanner is fantastic, it's easy, but here you have like a full control in a way in the code, and you can modify and make it your own. You can create this function block and have it on a library, so you can reduce it later. With the IO scanner, you just define everything over there, and it's visible here. You can like hide everything in a way in the code. Okay, so if I want, for example, to communicate to another device, okay, I just copy this, Control C, Control V, define the new ID, I don't know, number 20, define how I want to communicate this. Probably I have a sequence before, so if this one is finished, then I go to this one and then initialize everything over here. So you can duplicate, and then if you have, for example, a modification on the code for this device, to just add another one of this one that is always enabled in a way, but you just send the command to be executed. Okay, so that is the idea. So this is the next level of working with the function blocks. Have like a sequence and then put it together, everything in a just function block for the device that you want to communicate. So you have it and you have like your solution for this device. So and this is it for the function blocks, how we can communicate with a slave over Modbus serial using the PLC communication library, how we can improve the communication. Okay, so thank you very much for watching this video. I see you on the next one.